Have you ever wondered what it would feel like to be one of the last people on Earth? To look around and realize that your entire species is hanging by the thinnest thread imaginable? Well, 900,000 years ago, that nightmare scenario wasn't science fiction, it was reality. And the most shocking part? Almost nobody knew this happened until just recently. Right now, there are over 8 billion humans scattered across every corner of this planet. We've conquered deserts, built cities that stretch to the horizon, and sent our technology beyond the stars. We are everywhere. But if you could travel back in time to witness our world nearly 1 million years ago, you'd encounter something that would shake you to your core. Our entire human lineage was reduced to barely more than 1,000 breeding individuals. Think about that for a moment. 1,000 people. That's smaller than most high schools today. This isn't some ancient myth or speculative theory. This is hard science that emerged from one of the most groundbreaking genetic discoveries of our time. For those of you listening to fall asleep, that's exactly why I create these deep dives into history's most fascinating mysteries. So maybe hit that subscribe button and let me know in the comments where you're listening from and what time it is there. I love seeing how this content reaches people from Berlin at breakfast time to Boston at bedtime. The story I'm about to tell you will change how you think about humanity itself. It's a tale of survival against impossible odds, of genetic bottlenecks so severe they should have ended our story before it really began. And the crazy thing is, we only discovered this happened in the last few years. Scientists had suspected something dramatic occurred in our distant past, but nobody understood just how close we came to complete extinction. Picture this scenario. You're driving down a highway at night, and suddenly your headlights catch something massive directly ahead. You slam on the brakes, your heart pounding as you realize you missed a catastrophic collision by mere inches. That split second of terror when you realize how close disaster came. Now, imagine that feeling, but instead of lasting a moment, it stretched across more than 100,000 years. That's what happened to our species. The discovery began with a scientist named Wang Zhu at the Chinese Academy of Sciences. 5 years ago, he was conducting routine genetic analysis on modern human populations, the kind of standard research that happens in labs around the world every day. He was examining DNA samples from over 3,000 people representing populations from every continent, using these genetic signatures like a molecular clock to trace our evolutionary history backward through time. Then something extraordinary appeared in his data, something so dramatic and unexpected that he initially thought his equipment had malfunctioned. Around 900,000 years ago, the genetic signatures of human populations didn't just decline. They collapsed completely. It was like watching a movie where 99% of the characters suddenly vanished from the screen without explanation. The mathematical models were screaming that something catastrophic had occurred, but the numbers seemed impossible. If these calculations were accurate, then human ancestors had been reduced to a population smaller than a typical suburban neighborhood. Wang Zhu spent years double-checking his work, running the analysis again and again, using different methods and approaches. Every single time, the same terrifying result emerged. 98.7% of human ancestors were wiped out around 930,000 years ago. The survivors remained at critically low numbers for over 100,000 years. To put that timeline in perspective, that's longer than modern humans have existed as a distinct species. Now, you might think this sounds like just another tough period in evolutionary history. Species face challenges all the time, right? They bounce back from near extinction and continue evolving. But here's where this story becomes truly extraordinary. When populations crash to these levels, they almost never recover. Biologists have a term for what happens when breeding populations drop below 1,000 individuals. They call it the extinction vortex. In the extinction vortex, everything that can go wrong usually does. Genetic diversity plummets, leading to inbreeding and accumulated mutations. Random disasters that might barely affect a large population can completely eliminate a tiny one. A single drought, disease outbreak, or natural catastrophe becomes an existential threat. Most species that enter the extinction vortex simply disappear forever from the fossil record. But somehow, impossibly, our ancestors didn't disappear. For 117,000 years, through ice ages and droughts, through the extinction of countless other species around them, this tiny population of early humans held on. They kept the spark of humanity alive when every statistical model says it should have been extinguished. What makes this discovery even more incredible is the timing. 900,000 years ago places this population crash right in the middle of what geologists call the early Middle Pleistocene transition. This was when Earth's climate systems went completely haywire. Before this period, ice ages followed relatively predictable patterns, cycling roughly every 41,000 years. The planet would cool down, ice sheets would expand, then things would warm up again in a manageable rhythm. But around 900,000 years ago, everything changed. The Ice Age cycle shifted to brutal 100,000-year patterns. Glaciers became massive, covering enormous portions of the northern continents. Sea levels dropped by hundreds of feet as water became locked in ice. Ocean temperatures plummeted across the globe. For our ancestors living in Africa, this climate shift created a perfect storm of survival challenges. The continent didn't just become drier during this period, it underwent what scientists call aridification, a process so severe it transformed entire ecosystems. Lush woodlands where early humans had thrived for generations slowly transformed into scrublands, then into deserts, then into barren wasteland. Imagine being part of a small band of early humans during this time. Maybe you're Homo erectus or one of their descendants. The forests where your grandparents hunted are disappearing. Rivers that flowed year-round are becoming seasonal streams, then just cracked mudbeds. The animals your people have depended on for food are going extinct one by one. Plant foods are becoming increasingly scarce. This isn't a temporary drought that will end in a season or two. This is the new reality, and it's getting worse with each passing generation. Your small group moves constantly, following water sources that keep disappearing, tracking animal herds that keep shrinking, chasing hope that grows dimmer every year. The fossil evidence shows us just how devastating this period was for African wildlife. Species of antelope that had thrived for millions of years simply vanished. Elephant populations crashed. When the large animals die out, everything else in the ecosystem follows. Predators starve, scavengers starve, and anything that depends on hunting or scavenging faces an impossible choice between adaptation and death. Most early human populations chose poorly, or perhaps they simply ran out of options. They were wiped out completely. But somewhere in Africa, a tiny group found something the others missed. Maybe it was a mountain range that still caught enough rainfall to support scattered trees. Perhaps it was an underground water source that kept springs flowing when everything else dried up. It could have been a rift valley that created its own microclimate, providing just enough resources to sustain a small population. Whatever this refugee was, it worked. For more than 100,000 years, it kept our ancestors alive when survival should have been impossible. But here's where the story becomes even more fascinating. During this bottleneck period, something unprecedented happened to human genetics that would change our species forever. Two of our ancestral chromosomes fused together, merging into a single chromosome. This is why humans today have 46 chromosomes, while our closest relatives, chimpanzees and gorillas, have 48. Chromosome fusion is incredibly rare in evolutionary terms. It might happen once in millions of years under normal circumstances, but it happened right in the middle of our near-extinction event. This wasn't just a random coincidence. When populations are extremely small, unusual genetic changes can spread through the entire group much faster than would ever be possible in a large population. If one individual had this chromosome fusion and survived to reproduce, their children would carry it. In a population of only about 180 people, a genetic change like this could become universal within just a few generations. Today, every single human on Earth carries this fused chromosome, all 8 billion of us. It's called chromosome 2, and it contains the genetic signature of those desperate millennia when humanity nearly died out. Scientists can actually point to the exact molecular location where the fusion occurred. They can see the scars where two ancient chromosomes joined together, like forensic evidence from the most important crime scene in human history. But this chromosome fusion did more than just reduce our chromosome count. Some researchers believe it may have triggered crucial changes in brain development. Genes located near the fusion site affect neural function, and it's possible that the genetic reorganization during the bottleneck contributed to the evolution of larger, more complex human brains. Think about the implications of that. Our intelligence, our capacity for language, art, music, and abstract thought, our ability to create technology and build civilizations, all of it might trace back to a genetic accident that happened when there were fewer than 1,300 humans left on the entire planet. The evidence for this ancient bottleneck is embedded in our DNA like a time capsule from the most critical period in human history. Every person alive today carries the molecular fingerprint of those 117,000 years when our species balanced on the knife's edge between existence and oblivion. Population geneticists can read these genetic patterns like archaeologists examining artifacts. seeing the mathematical signature of near extinction written in the very code that makes us human. For decades, scientists knew something had happened in our distant past, but they couldn't quite piece together the full picture. Older genetic analysis methods were primitive by today's standards, like trying to read a complex novel through a keyhole. Researchers could detect that humans had experienced at least one major population bottleneck, probably when our ancestors first migrated out of Africa around 60,000 years ago. But they had no idea there was an earlier, far more severe crisis lurking in our genetic history. It took the development of revolutionary computational tools to finally crack this ancient code. Wangju and his team created new techniques that could analyze thousands of genomes simultaneously, tracing genetic changes back nearly 1 million years with unprecedented precision. When they first published their findings in the journal Science in 2023, the scientific community was stunned, not just because of how severe the bottleneck had been, but because of its extraordinary duration. Most population bottlenecks in evolutionary history are relatively brief affairs. A volcanic eruption devastates a region, wiping out most of a species, then the survivors rapidly multiply to fill the empty ecological niche. A disease sweeps through a population, eliminating 90% of individuals, but the remaining 10% recover within a few generations. These are dramatic but short-lived events. But 117,000 years? That's not a bottleneck in any conventional sense. That's more like an extended, near-death experience for an entire species. Nick Ashton, an archaeologist at the British Museum who reviewed the study, captured the magnitude perfectly when he noted that surviving for such an extended period would require a stable environment with sufficient resources and minimal stress on the system. In other words, somewhere in Africa during this climate catastrophe, there existed a pocket of relative stability, a refuge where a small group of early humans found everything they needed to survive while the rest of the continent was being ravaged by environmental collapse. But where exactly was this sanctuary? What made it so special? How did roughly 180 people manage to maintain a stable population for over 100,000 years while everything around them was dying? These questions keep researchers awake at night because their answers could unlock fundamental secrets about human resilience and survival. Some scientists theorize that the survivors clustered around reliable water sources, perhaps near the Great Lakes of East Africa or along rivers that continued flowing even when the climate turned hostile. Water attracts animals, animals provide food, and both water and food mean the difference between life and death. Others believe the key was technological innovation. Maybe these survivors had mastered fire control more effectively than other human populations. Fire changes everything about survival. It allows you to cook food, making nutrients more available and killing dangerous parasites. It keeps predators at bay during vulnerable nighttime hours. It extends your productive day, giving you more time to work, socialize, and plan. Most crucially, it lets you survive in environments that would otherwise be lethal. Archaeological evidence shows a sudden increase in fire use by human populations around 800,000 years ago. The timing aligns almost perfectly with when the genetic bottleneck ended and human populations began expanding again. This is probably not a coincidence, but here's something that will truly blow your mind. The fossil record from this entire period is almost completely empty. Between 950,000 and 650,000 years ago, there are virtually no human fossils found anywhere in Africa or Europe. Anthropologists used to call this the fossil gap and couldn't explain why our ancestors seemed to vanish from the archaeological record for hundreds of thousands of years. Now we understand why. There simply weren't enough humans around to leave fossils behind. With only 1,080 breeding individuals scattered across unknown territories, the chances of any of them dying under conditions that would preserve their bones for hundreds of thousands of years were vanishingly small. It's like searching for a needle in a haystack, except there are barely any needles and the haystack covers an entire continent. The few fossils we do have from this period come mostly from Europe and Asia, not Africa. These probably represent human populations that weren't directly part of the bottleneck, groups that managed to survive in slightly larger numbers in different regions. Africa is an enormous continent with incredibly diverse climates and ecosystems. While some areas became completely uninhabitable during the climate crisis, others might have remained relatively stable. But the genetic evidence is crystal clear. The ancestors of all modern humans, plus Neanderthals and the mysterious Denisovans, went through this extreme bottleneck together. We are all descendants of those 180 survivors. Every single person alive today carries DNA from that tiny population that refused to surrender during the worst climate crisis in human evolutionary history. Scientists estimate we lost approximately 65% of our total genetic diversity during the bottleneck. That's a staggering amount of lost variation. For comparison, the famous founder effect when modern humans first left Africa around 60,000 years ago only reduced our genetic diversity by about 15%. The bottleneck was more than 4 times more severe than that later migration event. This massive loss of genetic diversity has consequences we're still living with today. It explains why humans are unusually susceptible to certain infectious diseases compared to other mammals, why we have relatively weak immune systems compared to other primates, why genetic disorders that would be extremely rare in more genetically diverse populations show up with concerning frequency in human communities. In a twisted way, our vulnerabilities are proof of our greatest evolutionary triumph. Every genetic weakness we carry today is evidence that our ancestors were tough enough, smart enough, and cooperative enough to survive when survival seemed mathematically impossible. But the story doesn't end with mere survival. The most incredible part is what happened next. Around 813,000 years ago, something fundamental changed. The population of early humans began growing again, not slowly or gradually, but explosively. Within just a few thousand years, which is essentially instantaneous in evolutionary terms, the descendants of those 1,280 survivors had spread across Africa and begun expanding beyond the continent's borders. They weren't just recovering from near extinction. They were developing new technologies at an unprecedented pace. They created more sophisticated stone tools. They began hunting larger animals with greater efficiency. They started constructing more permanent shelters and controlling fire with systematic precision. Most importantly, they embarked on the evolutionary journey that would eventually produce three of the most successful species in human history. Modern humans, Neanderthals, and the enigmatic Denisovans all trace their lineage back to this post-bottleneck expansion. The timing is too perfect to be mere coincidence. Genetic evidence suggests that the last common ancestor of all three species lived right around the time the bottleneck crisis ended. It's as if the near-extinction event didn't just test our ancestors' survival abilities. It forged them into something entirely new, something stronger and more adaptable, something capable of not just surviving in a hostile world, but eventually dominating it completely. The genetic bottleneck wasn't simply an ordeal our ancestors endured, it was the crucible that created modern humanity. But what did daily life actually look like during those 117,000 years of evolutionary purgatory? What was it like to wake up every morning knowing your entire species hung by the thinnest possible thread? Let's step back into that world and try to understand what survival meant when there were fewer humans on Earth than students in a large university. It's 930,000 years ago, and you're part of one of these tiny bands of survivors. Maybe 30 or 40 individuals clustered together in whatever refuge your people have managed to find. The morning routine is deceptively simple. Wake up, locate water, secure food, avoid death. Repeat this cycle for the next 100,000 years. But simplicity doesn't mean easy. Every decision carries weight that's almost impossible for us to comprehend today. When your entire extended family represents a significant fraction of the human gene pool, losing even one person to accident, disease, or predation weakens the whole group in ways that cascade for generations. Water always came first. In a landscape where most streams had become seasonal trickles or bone-dry channels, knowing where to find reliable sources meant the difference between your band lasting another month or watching your children die of thirst. Your people probably developed an almost mystical ability to read the subtle signs of underground water. The way certain plants grew in barely perceptible lines across seemingly barren ground. How the behavior of insects and small animals could reveal hidden springs, which rocky outcroppings might conceal seeps that flowed even during the harshest dry seasons. You might have learned to dig rudimentary wells, nothing more than holes scraped out with sharpened sticks and flat stones. But even such crude technology could tap into groundwater sources that sustained a family through months when the surface world offered nothing but dust and death. Finding food required even greater ingenuity. With most large game extinct or driven to near extinction, traditional hunting strategies that had sustained your ancestors for hundreds of thousands of years simply didn't work anymore. Your people became what modern anthropologists call extreme dietary generalists. You ate absolutely everything that wouldn't kill you and probably experimented with some things that might. Insects became a crucial protein source. Termites, crickets, beetle larvae, grasshoppers, anything that crawled or flew and contained nutrients. Pound for pound, many insects are among the most nutritious foods on the planet. They reproduce quickly and in large numbers, which means even small populations can be harvested sustainably without destroying future breeding cycles. Underground plant foods became your lifeline. Roots, tubers, bulbs, anything that grew beneath the surface where it was protected from the scorching heat and endless drought. You learned which plants were edible during different seasons, which ones required careful preparation to remove toxins, which could be dried and stored for lean times that might stretch for months. Eggs represented precious windfalls of concentrated nutrition. Bird eggs, reptile eggs, anything containing the building blocks of life. You probably learned to track certain species to their nesting areas, timing your raids to maximize yield while ensuring enough eggs remained to maintain breeding populations. Even in desperation, you couldn't afford to eliminate the very food sources that might sustain you next season. And occasionally, when fortune smiled upon your struggling band, you encountered meat. Not the massive mammoths or giant deer that your more fortunate ancestors had hunted in coordinated groups of dozens. Those magnificent creatures were long gone, but smaller opportunities still presented themselves. A young antelope separated from its diminished herd. An aging elephant finally succumbing to drought and exhaustion. An injured predator, unable to defend its kill. This is where mastery of fire became absolutely critical for survival. Humans had been using fire for hundreds of thousands of years before the bottleneck, but during this crisis period, fire wasn't just a useful technology. It was the thin line between life and death. Cooking meat made it infinitely safer to consume, killing parasites and bacteria that could wipe out your entire family in a world where losing even one healthy adult was catastrophic. More importantly, cooking broke down tough proteins and made nutrients more bioavailable. You could extract significantly more calories from the same amount of precious food. Cooking plant foods was even more revolutionary. Many of the roots and tubers that kept you alive were completely indigestible or even toxic when consumed raw. But proper cooking transformed them into major sources of carbohydrates and essential nutrients. Some researchers believe this is when humans first developed systematic food processing techniques that would later become fundamental to our species' success. But fire provided benefits far beyond improved nutrition. It extended your productive day beyond the natural limits imposed by darkness. Without artificial light, most animals become helpless after sunset. Predators emerge to hunt, prey. Animals hide wherever they can, and everyone basically shuts down until sunrise brings safety and visibility. With controlled fire, your band could remain active long after dark. You could continue working on tools, repairing shelters, sharing crucial information about water sources or food discoveries. Most importantly, you could strengthen the social bonds that held your fragile group together. Those social bonds represented everything during the bottleneck period. With groups this small, you simply could not afford internal conflict. Every individual was precious beyond measure. Lose one adult to fighting, accidents, or disease, and the entire band's survival prospects dimmed significantly. Lose several people in a short period, and you might not have enough hands and minds to make it through the next harsh season. So your ancestors developed cooperation skills that would make modern diplomats envious. They learned to share resources even when those resources were desperately scarce. They mastered techniques for resolving disputes without violence. They cared for sick and injured members instead of abandoning them to die. Most crucially, they became obsessive about sharing knowledge. When someone in your band discovered a new water source, that information spread to everyone immediately. When a person figured out how to process a toxic plant to make it edible, that knowledge became common property within hours. When hunters developed a new technique for tracking elusive game, it was taught to everyone who could possibly benefit from it. This wasn't just altruism or kindness, though those qualities certainly played a role. It was hardcore survival strategy. In a population this small, losing accumulated knowledge when someone died could be absolutely catastrophic. Your people developed elaborate oral traditions, systematic teaching methods, and cultural practices designed to pass vital information from one generation to the next. Children weren't just taught basic survival skills. They were educated in everything: where to find water during each season of the year, which plants were safe to eat and which would kill you, how to read animal tracks and predict weather patterns, how to make and maintain the tools that kept everyone alive, how to recognize the subtle signs that indicated whether a seemingly safe area might harbor hidden dangers. Children who learned quickly had dramatically better chances of survival to reproductive age. Children who learned quickly and could effectively teach others had even better prospects for passing on their genes. Over thousands of generations, this created intense selective pressure for intelligence, for teaching ability, and for the capacity to acquire and transmit complex information rapidly and accurately. You were evolving into something unprecedented. Genetic evidence suggests that during the bottleneck period, human brain size began increasing measurably. Not the dramatic expansion that would come later, but a noticeable trend toward larger cranial capacity. This makes perfect evolutionary sense. When survival depends entirely on outsmarting your environment, natural selection strongly favors bigger, more capable brains, even if those brains require precious energy that was desperately scarce during the crisis. But it wasn't just raw intelligence that was evolving. Your ancestors were developing specifically social intelligence at levels never seen before in any species. Living in tiny groups for thousands of generations, they became incredibly skilled at reading other people's emotions, predicting behavior, knowing when to trust and when to be cautious, when to share and when to withhold resources. They developed what psychologists call theory of mind, the sophisticated ability to understand that other people have thoughts, intentions, and knowledge different from your own. This might sound simple, but it's actually one of the most complex cognitive abilities in the entire animal kingdom. Your ancestors were refining this capacity under the most intense survival pressure imaginable. The archaeological record from this period is frustratingly sparse, but what little evidence we have tells a fascinating story. Stone tools become more sophisticated, but also more standardized, as if small groups were developing consistent manufacturing techniques and sharing them widely across vast distances. Tools from the late bottleneck period show what archaeologists call cultural convergence. similar designs appearing in different regions at roughly the same time. This suggests communication networks between groups, trade routes, perhaps even regular gatherings where scattered bands would meet to exchange not just goods and resources, but knowledge and genes. Because here's something crucial to understand about those 280 breeding individuals. They weren't all crowded together in a single location. Basic population genetics tells us they had to be spread out across considerable distances. Concentrate everyone in one valley, and a single catastrophe could eliminate the entire human species in an afternoon. Evolution doesn't make that kind of fundamental mistake. These survivors were scattered, probably in groups of 20 to 30 people separated by hundreds of miles. Connected by networks of kinship and trade relationships, but living independently enough that no single disaster could destroy them all. This created what biologists call a metapopulation structure. Individual groups would rise and fall, sometimes thriving for generations, sometimes going extinct and being replaced by migrants from other successful bands. But the overall network persisted, like a desperate game where human populations were constantly emerging and disappearing, while the species as a whole clung to existence. For 117,000 years, this precarious balance continued. Some generations probably lived relatively well, finding territories with adequate resources and manageable challenges. Others endured terrible suffering, watching children die of starvation and disease while wondering if they represented the final chapter in human history. But somehow, impossibly, the network held together. And then, around 813,000 years ago, something fundamental shifted in their favor. The first signs were subtle. Slightly more reliable rainfall in some regions, grasslands beginning to expand again after millennia of desert, animal populations starting their slow recovery from near extinction. The most extreme phase of the climate crisis was finally ending, but by this time, your people weren't the same species that had entered the bottleneck. Those 117,000 years of relentless natural selection had transformed them completely. They had become smarter, more cooperative, better adapted to survive in harsh environments than any human population before or since. They had developed technologies that would have seemed like magic to their ancestors. More sophisticated tools, advanced fire management techniques, improved food processing methods that could extract nutrition from previously inedible sources. Most importantly, they had created social systems capable of maintaining cooperation and knowledge sharing across multiple generations, even under the most desperate circumstances. When environmental conditions finally began improving, they were ready. Population growth was explosive. Within just a few thousand years, descendants of those bottleneck survivors had spread back across Africa and begun expanding into Europe and Asia. They carried with them all the survival skills learned during the crisis years, plus genetic and cultural adaptations that had been tested under conditions that would have killed virtually any other large mammal species. These weren't just ordinary humans recovering from a difficult period. These were humans who had been forged in the ultimate evolutionary crucible. They were the ancestors of every human who would come after, and they carried within their genes and cultures the capacity to survive almost anything the world could throw at them. The bottleneck had ended but its effects would shape human evolution forever. What happened next would determine which of our ancestors' descendants would inherit the earth, and why modern humans ultimately succeeded where others failed. The explosion of human population after the bottleneck wasn't just a simple recovery story. What emerged from those desperate millennia was something unprecedented in evolutionary history. Around 800,000 years ago, that single population of survivors began fragmenting into three distinct evolutionary paths that would reshape the entire planet. Think of it like a river that's been forced through the narrowest possible channel for over 100,000 years. All that evolutionary pressure builds up behind the constraint. Then suddenly, you remove the bottleneck, and the water doesn't just flow forward. It erupts in multiple directions simultaneously, carving entirely new channels through the landscape. The first group remained in Africa, but they weren't standing still. These populations faced a continent that was recovering, but still unpredictable. Climate patterns continued shifting every few generations. Resources appeared and disappeared without warning. Animal populations fluctuated wildly as ecosystems struggled to find new equilibrium. This ongoing environmental instability kept intense selective pressure on the African populations. They couldn't specialize for any single set of conditions because those conditions kept changing. Instead, natural selection favored adaptability itself. Intelligence, problem-solving ability, the capacity to develop new technologies rapidly when circumstances demanded it. Over hundreds of thousands of years, this population developed what we now recognize as the defining characteristics of modern humans. Larger brains relative to body size, more gracile bone structure, enhanced capacity for symbolic thinking. Most crucially, they developed behavioral modernity, the ability to create art, use complex symbols, engage in abstract reasoning, the complete mental toolkit that would eventually allow them to dominate every environment on Earth. But that dominance was still far in the future. For now, they were simply one of three human species, all competing for resources in a world still recovering from the greatest climate disaster in our evolutionary history. The second group moved north and west into Europe and Western Asia. These migrants encountered a radically different world than their African homeland. Colder, more seasonal, dominated by massive ice sheets that created entirely new survival challenges. But they adapted with stunning speed. Within a few 100,000 years, these populations had developed the robust builds, enlarged nasal passages, and cold weather adaptations that made them perfectly suited for Ice Age Europe. They became the Neanderthals, and they were magnificent survivors in their own right. Neanderthal skeletons reveal bone density and muscle mass that would make modern athletes jealous. They developed massive nasal cavities to warm and humidify the frigid air they breathed. Their brains actually grew larger than those of modern humans, possibly as an adaptation to the complex cognitive demands of Ice Age survival. But their most impressive achievement was cultural. Neanderthals became master hunters, not just opportunistic scavengers like many earlier human species, but systematic strategic predators capable of taking down massive Ice Age mammals. They developed sophisticated spear-throwing techniques, learned to hunt in coordinated groups that could drive large animals into carefully planned kill zones. They figured out food preservation methods that could sustain them through brutal 8-month winters, probably using natural refrigeration in caves and permafrost. Most remarkably, they developed the first systematic burial practices in human history. Neanderthal graves show evidence of intentional placement, sometimes with grave goods, suggesting they had developed symbolic thinking, the ability to conceive of death as something meaningful and worthy of ritual attention. The third group went east, spreading across Asia and eventually reaching as far as Indonesia and New Guinea. We know less about their specific adaptations because they left fewer fossils, but we know they existed because their DNA still appears in modern populations across Asia and Oceania. These were the Denisovans, and they were incredibly successful in their own mysterious ways. Genetic analysis of modern Asian populations reveals Denisovan DNA signatures from the Philippines to Tibet, indicating they spread across an enormous range of environments and developed remarkable specializations. Some Denisovan populations adapted to extreme high altitudes, evolving genetic variants that helped them process oxygen more efficiently in the thin air of the Himalayan plateau. These same genetic adaptations show up in modern Tibetan populations today. Clear evidence that ancient humans and Denisovans interbred and passed on survival genes that are still helping people thrive at elevations that would incapacitate most other humans. Other Denisovan groups seem to have become skilled seafarers. Archaeological evidence suggests they reached islands in Southeast Asia that would have required sophisticated boat-building and navigation technologies. This means they developed maritime capabilities thousands of years before any other human species even attempted ocean travel. Here's what makes this three-way split absolutely incredible. Despite spreading across 3 continents and adapting to completely different environments for hundreds of thousands of years, all 3 groups remained genetically compatible. They were still fundamentally the same species, still carrying the chromosomal fusion that marked them as bottleneck survivors. Modern humans and Neanderthals interbred when our ancestors finally migrated out of Africa around 60,000 years ago. Denisovans interbred with both Neanderthals and modern humans at various times and places. Genetic evidence shows multiple episodes of interbreeding spanning hundreds of thousands of years. This tells us something profound about the bottleneck's legacy. Those 117,000 years of near extinction had created a kind of genetic unity among all human populations. Despite evolving along different paths for almost 500,000 years, we remained one species at the deepest level, all still sharing the basic genetic toolkit that had been refined during those desperate millennia of survival. But each group was also developing specialized survival strategies that would define their particular evolutionary trajectory. The archaeological record from this period shows an explosion of technological innovation happening simultaneously among all 3 populations. In Africa, stone tool technology became increasingly sophisticated. The simple hand axes that had dominated human toolkits for millions of years gave way to carefully crafted spear points, scrapers, and cutting implements designed for highly specific tasks. More importantly, tool manufacturing became standardized across vast distances. Archaeological sites from across the African continent show remarkably similar tool designs appearing at roughly the same time periods. This suggests widespread communication networks and systematic knowledge sharing between groups separated by hundreds or even thousands of miles. Ideas were spreading faster than genes, allowing rapid adaptation to new challenges and opportunities. In Europe, Neanderthals were developing their own technological traditions that were equally impressive. They created the first hafted tools in human history, spear points and knives carefully attached to wooden handles, using plant resins and animal sinews. This might sound simple, but it represents a major cognitive leap forward. Creating hafted tools requires planning ahead, gathering multiple different materials, and understanding abstract concepts like torque and leverage. You have to envision the finished product before any of the components exist, then execute a complex manufacturing process that combines organic and inorganic materials in precise ways. Neanderthals also developed what archaeologists call prepared core techniques for stone tool production. Instead of just chipping away at rocks until they got something useful, they learned to carefully shape stone cores so they could produce multiple identical tools from a single piece of raw material. This represents planned, systematic manufacturing of standardized goods. The Denisovans were innovating too, though their achievements are harder to trace in the archaeological record. Genetic analysis suggests they were the first human species to develop systematic use of plant medicines. Modern Asian populations carry Denisovan gene variants that help process plant toxins, indicating their ancestors had learned to use poisonous plants as medicines and developed genetic resistance through natural selection. They might also have been the first humans to practice systematic agriculture. Some researchers believe the genetic variants that help modern Asian populations digest starchy foods efficiently originated with Denisovans, who had learned to cultivate and process wild grains. But perhaps the most important innovation happening during this period was in the realm of social organization. All three post-bottleneck human species were developing increasingly complex social structures that went far beyond anything seen in earlier human populations. Extended family groups were forming alliances with other groups. Trade networks emerged that could move raw materials and finished goods across hundreds of miles. Marriage systems developed that systematically exchanged partners between distant communities, maintaining genetic diversity while strengthening social bonds. This wasn't just survival anymore. This was the foundation of civilization itself. The genetic evidence for this social revolution is embedded in our DNA. During the post-bottleneck expansion, human populations show what geneticists call structured breeding patterns. Not random mating within local groups, but systematic exchange of marriage partners between communities. This indicates our ancestors had developed kinship systems with rules about who could marry whom. Probably elaborate gift exchange networks that maintained relationships between distant communities across generations. They were creating the social frameworks that would eventually allow human societies to scale up from small bands to tribes, then chiefdoms, and ultimately complex states. They were also creating something else that would prove even more transformative in the long run. Language as we know it today probably emerged during this post-bottleneck period. Nobody knows exactly when human language evolved because spoken words don't fossilize, but everything points to this era as when our communication abilities became truly sophisticated. The rapid spread of standardized technologies suggests complex information transfer capabilities. The evidence of long-distance trade networks implies negotiation skills and abstract reasoning. The burial practices indicate symbolic thinking. Most tellingly, the genetic bottleneck had created exactly the conditions under which complex language would provide massive survival advantages. Small, scattered populations trying to maintain connections across vast distances. Groups that needed to share detailed information about resources, dangers, and opportunities. Individuals whose survival depended on their ability to learn complex skills quickly and teach them effectively to their children. Under these conditions, any improvement in communication ability would provide enormous evolutionary benefits. People who could speak more clearly, understand more precisely, or convey information more effectively would be significantly more likely to survive and reproduce successfully. Over hundreds of generations, this selection pressure would refine human communication abilities far beyond anything seen in other species. By the time the three human species encountered each other again, they would have been capable of sophisticated verbal communication. They could share knowledge, negotiate alliances, even tell stories about their ancestors who had survived the Great Crisis. But they were also starting to face entirely new challenges. The world was filling up again. Resources that had been abundant during the early recovery period were becoming contested. The three human species were beginning to compete directly for the same territories and the same crucial resources. The age of cooperation was ending. The age of competition was about to reshape human evolution once more. What happened next would determine which lineage would ultimately inherit the earth, and why only one of these three remarkable species would survive to build the modern world. Around 60,000 years ago, the descendants of those African survivors made a decision that would change everything. A small group, perhaps just a few hundred individuals, chose to leave their ancestral homeland and cross the narrow waters separating Africa from the Arabian Peninsula. They had no idea they were about to encounter their long-lost evolutionary cousins. For over 400,000 years, the three human species had been evolving in complete isolation. Modern humans in Africa, Neanderthals in Europe, Denisovans across Asia. Each had become perfectly adapted to their specific environments, developing unique technologies, distinct cultures, specialized survival strategies. Now, they were about to meet face to face for the first time since their ancestors had emerged from the bottleneck together. The encounters that followed would be unlike anything in evolutionary history, and their consequences would echo through time to shape the world we inhabit today. The first encounter probably happened somewhere in the Middle East, perhaps along the eastern shores of the Mediterranean, where African migrants would have first encountered the southern edge of Neanderthal territory. Imagine that moment from the perspective of both groups. You're a modern human, part of a small exploration party venturing into unknown lands. Your people have never seen other humans who look fundamentally different from yourselves. Then suddenly, across a valley or riverbank, you spot them. They're unmistakably human, but something feels off. Shorter than your people, with incredibly robust builds. Faces that project forward dramatically, featuring massive brow ridges and enormous nasal openings. Bodies constructed like natural bodybuilders, all dense muscle and thick bone structure. These are Neanderthals, your evolutionary cousins, separated by nearly 500,000 years of independent development. Your first instinct might be fear, curiosity, maybe even aggression. We'll never know exactly what those initial meetings were like, but we know what happened next because it's permanently recorded in our genetic code. They didn't just fight for territory or resources. They formed relationships. They had children together. Modern humans and Neanderthals interbred repeatedly over thousands of years. Today, everyone of non-African descent carries approximately 2% Neanderthal DNA. That's the genetic signature of those ancient encounters, permanent proof that when our species first met, at least sometimes they chose cooperation over conflict. But cooperation has natural limits, especially when resources are scarce. The Middle East during this period functioned like a revolving door between species. Climate patterns would shift, and modern humans would expand northward into Neanderthal territory. Then climate would shift again, and Neanderthals would push back south, reclaiming lands their ancestors had occupied for millennia. For tens of thousands of years, control of this crucial region changed hands repeatedly. Sometimes modern humans controlled the prime hunting grounds and water sources. Sometimes Neanderthals dominated the landscape, but neither group could establish permanent dominance until something fundamental changed the rules of competition. Around 45,000 years ago, modern humans developed what archaeologists call the Upper Paleolithic Toolkit, a revolutionary collection of technologies that made them dramatically more effective hunters and gatherers. Sophisticated spear throwers that could launch projectiles with deadly accuracy across much greater distances. Bone needles that allowed creation of fitted clothing for harsh weather conditions. Fish hooks and nets that opened up entirely new aquatic food sources. Most importantly, they perfected systematic blade production techniques for creating long, razor-sharp cutting edges from minimal amounts of stone material. These innovations weren't just incremental improvements. They were force multipliers, technologies that allowed smaller groups of humans to accomplish what had previously required much larger populations. A Neanderthal hunting party might need 20 people working together to successfully take down a mammoth. A modern human group equipped with spear throwers and coordinated tactical approaches could achieve the same result with 8 individuals. This efficiency advantage compounded over time, creating cascading effects that transform the competitive landscape. Modern humans could maintain control over larger territories with smaller populations. They could survive and thrive in marginal environments that would challenge even the incredibly robust Neanderthals. They could expand into new regions faster and establish permanent settlements more easily than their evolutionary cousins. The Neanderthals, who had survived multiple ice ages through sheer physical toughness and incredibly tight-knit group cooperation, suddenly found themselves systematically outcompeted by a more technologically sophisticated species. But they certainly didn't surrender without resistance. Archaeological evidence from this period reveals increasing violence between human groups. Neanderthal sites contained significantly more weapons than earlier periods. Modern human settlements show clear evidence of fortification and defensive planning. Skeletal remains from both populations bear unmistakable marks of interpersonal conflict and organized warfare. This wasn't genocide in any systematic sense. It was intense competition for identical resources by two species that had become similar enough to want exactly the same things: water sources, prime hunting territories, shelter sites, raw materials for tool production. The stakes couldn't have been higher, and increasingly, modern humans were gaining decisive advantages. Not because they were physically stronger. Neanderthals were superior in almost every measure of raw physical capability. Not because they were more intelligent. Neanderthal brains were actually larger on average than those of modern humans. They succeeded because they were more flexible and adaptable. Neanderthals had spent hundreds of thousands of years perfecting survival strategies specifically designed for Ice Age Europe. They had become incredibly skilled at what they did, but their expertise was highly specialized for particular environmental conditions. Modern humans, products of the constantly changing African recovery environment, had been selected for adaptability itself rather than specialization. They could rapidly modify tactics when circumstances changed. They could exploit new food sources that Neanderthals might overlook. They could adjust their tools and techniques to handle unfamiliar challenges with remarkable speed. When climate patterns shifted, which happened frequently during this period, modern humans adapted quickly while Neanderthals struggled with strategies that had become too rigid. Gradually, inevitably, Neanderthal populations began shrinking. First, they lost control of the most valuable territories: river valleys with reliable water sources, coastal areas rich in marine resources, the prime hunting grounds where large game animals gathered seasonally. Then they found themselves pushed into increasingly marginal regions: mountain valleys, northern forests, areas that modern humans didn't yet want or couldn't easily exploit. By 28,000 years ago, the last Neanderthal populations were clinging to existence in southern Spain and Gibraltar, isolated communities surviving in refuges that grew smaller every generation. Then, after nearly 500,000 years of evolutionary success, they simply vanished from the fossil record forever. The story unfolding simultaneously in Asia followed similar patterns, but with important differences. Modern humans encountered Denisovans sometime around 50,000 years ago. We know much less about these meetings because Denisovan fossils are extraordinarily rare. Most of our knowledge comes from genetic analysis rather than archaeological evidence. But DNA tells a remarkably clear story. Like the situation with Neanderthals, there was extensive interbreeding between modern humans and Denisovans. Modern Asian populations carry Denisovan genetic variants, with some Pacific Islander populations containing as much as 6% Denisovan ancestry. Unlike the European situation, there seems to have been less direct competition between modern humans and Denisovans initially. Asia was vast enough that different groups could occupy distinct ecological niches for extended periods without direct conflict. Denisovans who had adapted to extreme high altitudes continued thriving in mountain regions. Those who had become seafaring specialists maintained control of island chains and coastal territories. Modern humans initially occupied complementary regions like river valleys and coastal plains, areas that supplemented rather than directly competed with established Denisovan territories. This allowed both species to coexist for longer periods than had been possible in Europe's more constrained geography. But eventually, the same technological and demographic pressures that had eliminated Neanderthals began affecting Denisovan populations too. Modern humans were simply more efficient at extracting resources from any given environment. They could support larger populations in the same territories, expand faster into new regions, and establish permanent settlements more easily than their evolutionary competitors. One by one, Denisovan populations were absorbed through interbreeding, outcompeted for crucial resources, or displaced to increasingly marginal territories. Some groups may have survived until surprisingly recent times. Tantalizing genetic evidence suggests modern humans were still encountering Denisovan populations in Southeast Asia as late as 25,000 years ago. But eventually, they too disappeared as distinct populations. By 20,000 years ago, Homo sapiens were the only human species remaining on Earth. The descendants of those 180 bottleneck survivors had outlasted their evolutionary cousins, who had also descended from the same tiny ancestral population. The three-way evolutionary split that had begun 800,000 years earlier was finally resolved. But why did modern humans ultimately succeed where Neanderthals and Denisovans failed? The answer brings us full circle back to that ancient bottleneck and its lasting evolutionary consequences. Those 117,000 years of near extinction had selected for specific traits in all three species: intelligence, cooperation, technological innovation, adaptability. But the African population that became modern humans had faced one additional challenge that their European and Asian cousins had managed to avoid. Africa had remained climatically unstable even after the worst phase of the crisis ended. While Neanderthals adapted to the relatively predictable patterns of Ice Age Europe, and Denisovans specialized for specific Asian environments, modern humans had to keep adapting to constantly shifting conditions. Droughts lasting decades followed by periods of catastrophic flooding. Seasonal patterns that changed every few generations. Animal populations that appeared and disappeared unpredictably as ecosystems struggled to find stability. This ongoing environmental pressure had kept modern humans evolutionarily flexible in ways that extreme specialization simply couldn't match. When the three species finally encountered each other after hundreds of thousands of years of separate development, Neanderthals and Denisovans were like finely tuned racing cars, incredibly efficient under the right conditions, but difficult to modify when circumstances demanded different approaches. Modern humans were more like all-terrain vehicles, not perfectly optimized for any single environment, but capable of handling whatever challenges came next. This flexibility manifested in multiple crucial ways. Technologically, modern humans innovated constantly, developing new tools and techniques every few thousand years. Neanderthals used essentially identical stone tool technology for over 200,000 years. It worked brilliantly, so they maintained traditional approaches. Socially, modern humans formed larger, more complex networks that could mobilize greater numbers for major hunts or territorial conflicts. They developed trade relationships that moved resources across hundreds of miles, creating economic advantages that smaller, more isolated groups couldn't match. Demographically, modern human populations could grow faster and recover more quickly from setbacks. When disease outbreaks or climate disasters reduced group numbers, they bounced back within a few generations, rather than struggling for millennia. Nutritionally, modern humans became extreme dietary generalists, consuming everything from shellfish to mammoth meat to systematically processed plant foods. Neanderthals remained focused primarily on large game hunting, which was highly effective but vulnerable when climate changes affected prey populations. But perhaps most importantly, modern humans had developed more sophisticated communication abilities than their evolutionary relatives. The genetic bottleneck had created selection pressure for complex language in all three species. But modern humans dealing with more variable environments and larger social networks had pushed verbal communication the furthest. They could coordinate large group activities more effectively, share complex technical knowledge more accurately, and maintain relationships across greater distances and longer time periods. When modern humans encountered Neanderthal or Denisovan groups, they weren't just competing for resources. They were competing with communication and organizational advantages that had been 400,000 years in the making. It wasn't remotely a fair competition. By 15,000 years ago, modern humans had spread to every continent except Antarctica. They had developed agriculture, established permanent settlements, and created complex societies with sophisticated division of labor. The population that had once numbered only 1,280 individuals now included millions of people speaking hundreds of distinct languages. They had inherited all the survival skills that had carried their ancestors through the bottleneck crisis. But their evolutionary cousins had never quite achieved. They had also developed something entirely new. The ability to not just adapt to their environment, but to systematically reshape it according to their needs and desires. The age of human dominance had officially begun, and it all traced back to those desperate millennia when survival hung by the thinnest possible thread, when 1,280 individuals somehow refused to surrender to extinction. So here we are today, 8 billion humans scattered across every habitable corner of this planet. Tokyo houses 14 million people in its metropolitan area. Lagos contains over 15 million, New York, London, Mumbai, São Paulo. Cities so massive they glow like artificial galaxies when viewed from space against the dark earth below. We've constructed global communication networks that connect every inhabited region instantaneously. We've decoded our own genetic blueprint and sent robotic explorers to other planets. We've created art that moves people to tears and music that makes strangers dance together in celebration of our shared humanity. We are unquestionably the most successful species in the entire history of life on Earth. And every single one of us, every person listening to this story right now, every child being born at this moment, every human who has ever lived, carries within our cells the genetic signature of those 1,280 individuals who refused to give up 900,000 years ago. That realization should stop you completely in your tracks when you truly absorb its implications. Your DNA contains molecular sequences that survived the worst climate disaster our lineage ever faced. Genes that endured 117,000 years of near extinction and emerged stronger. Chromosomes that fused under impossible pressure and somehow enhanced rather than diminished our capabilities. The way your brain processes information, solves problems, cooperates with strangers, learns language, cares for children, all of it was fundamentally shaped by those desperate millennia when survival required every conceivable advantage. You are living proof that sometimes, against all mathematical odds, life discovers a way forward. But this discovery represents more than just a fascinating origin story. It explains profound truths about why humans behave the way we do today. Ever wondered why we're so much better at large-scale cooperation than other primates? Why humans can work together in groups of hundreds or thousands while chimpanzees struggle to maintain cohesion beyond 50 individuals? It's because our ancestors spent over 100,000 years in populations so small that cooperation wasn't merely useful. It was the absolute requirement for anyone's survival. Individuals who couldn't collaborate effectively with others died without reproducing. Those who could share resources, teach skills, and work harmoniously lived long enough to pass on their cooperative genes. For 4,000 generations, natural selection relentlessly refined our capacity for collaboration under the most extreme survival pressure imaginable. We didn't just survive the bottleneck. We became evolutionarily addicted to learning and sharing what we discovered. Ever wondered why humans are uniquely obsessed with teaching? Why we spend years of our lives showing children how to do things that other animals learn through simple trial and error? It's because during the bottleneck period, losing accumulated knowledge when someone died could doom entire communities. Our ancestors who excelled at transferring information to younger generations had dramatically better survival odds over thousands of years. This created the teaching instinct that allows human societies to accumulate knowledge across generations, rather than starting from scratch with each new cohort. Ever wondered why we're so remarkably skilled with tools? Why humans can master everything from stone hammers to smartphones, while even highly intelligent animals like dolphins use tools only in extremely limited ways? It's because tool making and tool use were literally matters of life and death during the crisis years. Individuals who could innovate, who could discover better methods for obtaining food or controlling fire or constructing shelter, were significantly more likely to survive long enough to reproduce successfully. We evolved into a species that perceives the entire world as raw materials for solving whatever problems we encounter. But the bottleneck also explains some of our most troubling vulnerabilities. Ever wondered why humans are so unusually susceptible to infectious diseases compared to other mammals? Why we're devastated by viruses that barely affect other primates? It's because we lost 65% of our genetic diversity during the bottleneck. That massive reduction includes countless immune system variants that might have protected us from various pathogens. We're all much more genetically similar than we should be for a species our current size, making us vulnerable to diseases that can exploit our common genetic weaknesses. Ever wondered why genetic disorders like sickle cell anemia or Huntington's disease persist in human populations when natural selection should theoretically have eliminated them? It's because some of these conditions might have provided survival advantages during the bottleneck period, or they might represent side effects of other traits that were strongly selected for during the crisis. When you're reduced to 1,280 individuals, genetic variation that would normally disappear can become permanently locked into the entire species. We carry both the scars and the strengths of near extinction in our very cells. But perhaps the most profound implication of this discovery concerns human unity itself. Right now, there are people who believe that racial differences between human populations represent meaningful biological distinctions. People who think that groups with different physical appearances or languages are fundamentally different types of humans. The bottleneck discovery completely demolishes that kind of thinking. Everyone on Earth, absolutely everyone, descends from the same tiny group of 1,080 individuals who lived 900,000 years ago. We've only been separated for a few tens of thousands of years, which represents virtually nothing in evolutionary terms. Wow! The genetic differences between any two human populations anywhere on the planet are smaller than the variation you'd find within a single population of chimpanzees. We are all cousins, remarkably recent cousins sharing an incredibly recent common ancestry. When humans finally migrated out of Africa 60,000 years ago and spread around the world, they carried bottleneck DNA to every continent they reached. When they developed different skin colors and facial features to adapt to new climates, they were simply expressing different combinations of the same underlying genetic toolkit. The Aboriginal Australians who reached their continent 50,000 years ago. The Europeans whose ancestors survived Ice Age conditions. The Polynesians who navigated across the Pacific using sophisticated star charts. The Native Americans who crossed into the Americas during the last glacial period, all carrying genes from those 1,280 survivors, all products of the same evolutionary crucible. There is no meaningful them in human genetics. There's only us, and us has always been one extended family, shaped by the identical history of survival against impossible odds. This has tremendous implications for how we approach modern challenges, too. Climate change, for instance. Right now, we're facing another period of rapid environmental transformation. Not as severe as what our ancestors endured 900,000 years ago, but serious enough to threaten the stability of human civilization. The bottleneck discovery suggests we have reasons for both deep concern and genuine hope. Concern because past climate disasters have brought human populations to the very brink of extinction. We're not invulnerable simply because we're technologically advanced or numerous, but hope because we carry within our genes the legacy of the ultimate survivors. The ancestors who made it through the bottleneck weren't just fortunate. They were adaptable, innovative, cooperative. They were willing to completely transform their way of life when circumstances absolutely demanded it. Those traits remain embedded in us today. The same flexibility that allowed our ancestors to survive the transition from forest to savanna to desert. The same cooperation that held tiny populations together through millennia of crisis. The same problem-solving ability that developed new technologies when traditional approaches stopped working. We are not the same species that entered the bottleneck 930,000 years ago. We are the species that emerged from it. Tested, refined, proven capable of surviving conditions that would eliminate almost any other large mammal on the planet. So here we stand, 8 billion strong, the living descendants of humanity's darkest hour. Every laugh, every tear, every dream you've ever had traces back to those 180 individuals who looked at a world falling apart around them and decided to keep going anyway. We are their legacy, their triumph, their promise that some